NASA's scientific instruments aboard its missions have given the United States an unparalleled ability to monitor Threeey Atlas. A strange presence from deep space has made itself known. A mysterious object has released a signal. A faint shimmer rippled across the surface of Threeey Atlas. An interstellar body, long believed to be nothing more than another drifting fragment of cosmic debris, as astronomers tracked its movement along the outer boundary of the solar system. The initial flash was dismissed as a technical irregularity, a fleeting error caused by distance, interference, or stress sensors. But the shimmer returned. It appeared again, steady and rhythmic, forming a pattern that could no longer be ignored. When the sequence repeated for a third time, monitoring stations around the world registered the same alert. This was not random light. It was structured. It appeared deliberate. The announcement that followed from NASA disrupted the long-held assumption that interstellar visitors were silent, lifeless rocks wandering through the dark. It confirmed that humanity was witnessing something deeply unusual, something that seemed to illuminate itself with intent rather than chance. Until this moment, the story of Threeey Atlas had followed familiar expectations. Like Oumuamua and Borisov before it, Atlas was assumed to be a fragment expelled from a distant star system, traveling alone across immense cosmic distances over millions of years. When its trajectory was confirmed and telescopes were trained on it, scientists anticipated another rare opportunity to study pristine material from beyond the sun's influence. Instead, they encountered luminous pulses appearing with mathematical regularity, flashes that seemed far too precise to be explained by geology or chemistry. NASA's public remarks acknowledge the anomaly in measured, careful language, yet the implications hidden beneath that restraint sent shockwaves through the global scientific community and beyond. What made the emissions extraordinary was not just their visibility, but their consistency. Light from comets or icy bodies typically arises from outgassing or reflected sunlight, processes that fluctuate and weaken at great distances. Yet Threeey Atlas was far too remote from the sun for such mechanisms to generate stable, repeating signals. The timing of the pulses did not correspond to rotational wobble or changing reflectivity. As more data was collected, astrophysicists noticed that the intervals between flashes aligned with ratios seen in orbital dynamics and harmonic sequences. These were not chaotic eruptions from trapped gases. They were regular, measured, and almost clock-like in their precision. As NASA's analysis deepened, it became increasingly difficult to attribute the phenomenon solely to natural causes. The decision to address the signals publicly was made with caution. When the agency finally spoke directly, it emphasized scientific discipline and transparency, explaining that the light patterns were genuine, repeatable, and independently confirmed by observatories across continents and across multiple wavelengths. They were not sensor artifacts, satellite reflections, or cosmic ray interference. The emissions originated from the object itself. In that moment, a subtle but profound shift occurred in human perspective. A species accustomed to observing a silent universe was forced to consider the unsettling possibility that observation might not be one-sided. Part of the fascination lay in the source of the signals. Unlike distant radio bursts or enigmatic emissions from far-off galaxies, these lights originated from a tangible object moving within the solar system. That proximity compelled scientists to confront possibilities that had previously remained largely theoretical. If the light was artificial, did that imply technology, a probe, or a vessel? Or could it be something far older and more obscure, perhaps a relic of a civilization that no longer exists, drifting aimlessly until gravity carried it briefly into humanity's reach? NASA offered no conclusions, but the acknowledgement of such questions alone was enough to spark unprecedented scrutiny. Telescopes already focused on Atlas refined their observations, capturing the oscillations with growing clarity. Some instruments detected faint thermal signatures inconsistent with a cold, inert body. Others recorded subtle variations in speed and rotation that hinted at controlled orientation rather than random motion. None of these findings amounted to definitive proof of technology, yet together they formed a pattern too unusual to dismiss. Complicating matters was Atlas's speed. Interstellar objects travel rapidly, largely unaffected by the sun until they plunge deep into the system. Atlas followed a sharply hyperbolic path, leaving scientists with only a narrow window for detailed study before it curved around the sun and vanished back into interstellar space. This urgency amplified the importance of the light pulses. They were not trivial curiosities. They might represent the only interaction humanity would ever have with this object. As research continued, some scientists explored the idea that the luminosity could reflect autonomous activity rather than conscious intent. Artificial light does not require active intelligence. It could be the residual operation of a long-abandoned machine still running ancient instructions. In that case, Atlas might be a derelict artifact launched ages ago by a civilization that never anticipated contact. Even this restrained interpretation was staggering, as it implied that technological life had once existed elsewhere in the galaxy with the capacity to send objects between stars. Such a discovery would fundamentally alter humanity's understanding of its place in the cosmos. Another cautiously discussed possibility was that the light served an observational function. Data suggested that the wavelength of the pulses shifted slightly as Earth rotated into and out of alignment with the object. While this could be coincidence, it raised unsettling questions. Were the emissions part of a scanning system, a navigational aid, or an attempt at communication? Or were they simply maintenance cycles of an alien device, entirely indifferent to the life watching it from afar? Regardless of interpretation, the implications extended far beyond astronomy, touching philosophy, anthropology, and the collective human psyche. The signals also prompted scientists to re-examine earlier encounters with interstellar visitors. Oumuamua's unusual shape and unexplained acceleration had already inspired speculation about artificial origins, though evidence remained inconclusive. Now, with Threeey Atlas displaying structured light, past assumptions were being reconsidered. If one interstellar object exhibited signs of artificial behavior, others might have done so unnoticed. Perhaps such technology was not exceedingly rare, and humanity had only recently developed instruments sensitive enough to detect it. Within NASA, teams worked to identify a plausible mechanism behind the emissions. Some proposed exotic natural processes involving unusual ices and magnetic interactions. But the precision of the timing undermined these ideas. Piezoelectric effects caused by internal stress were also considered. Yet such phenomena could not account for the recorded regularity. Each attempt to explain the lights using known physics encountered contradictions. While an unknown natural process could not be entirely ruled out, it appeared increasingly strained. Alongside scientific debate, cultural reaction unfolded rapidly. For decades, extraterrestrial technology had largely belonged to fiction and speculation. Now, there existed an officially acknowledged astronomical anomaly that resisted straightforward explanation. Writers, artists, philosophers, and commentators grappled with its meaning. Threeey Atlas did not arrive as a dramatic landing or a direct message. Instead, it passed silently, glowing faintly, offering a subtle yet powerful glimpse of what encountering alien technology might actually look like. The rhythm of the pulses became the center of intense speculation. Their precision and mathematical relationships suggested purpose. Yet purpose without context is nearly impossible to interpret. If information was embedded within the signals, decoding it would require an understanding of the sender's logic and perception of reality. The emissions might not be communicative at all. They could simply represent operational cycles that help a machine maintain stability or orientation as it drifts among the stars. Scientists remain cautious, resisting the urge to impose human meaning on something fundamentally unfamiliar. Equally compelling was the question of scale. If Atlas contained technology, it might only be a fragment of something far larger. It could be a probe sent to explore the galaxy or a discarded component from an ancient mission. It might even be a remnant of a massive structure broken apart by time and gravity. The lights could be the final functioning systems of a device otherwise worn down by eons of interstellar travel. Such possibilities underscored how little humanity might be seeing, a single shard of a vast and incomprehensible history. NASA's observations also raise questions about the object's age. Traveling between stars at sublight speeds requires immense time. Atlas could be millions of years old. Its creators may have risen and vanished long before humans existed. In that light, The pulses could represent the last echo of a civilization whose only surviving legacy drifts silently through space. This idea resonated deeply, suggesting a universe filled with relics of lost intelligences. Silent witnesses awaiting the rare moment when a young species becomes capable of noticing them. The discovery reignited debate over the limits of human interpretation. When confronted with phenomena that defy existing models, scientists often oscillate between extraordinary explanations and extreme caution. In the case of Threeey Atlas, this tension was unmistakable. Some urged restraint, insisting that every possible natural explanation must be exhausted. Others felt that this anomaly represented exactly the kind of evidence humanity had long anticipated, a subtle indication that it might not be alone. NASA's responsibility lay in balancing these perspectives, presenting the data without sensationalism while acknowledging its profound strangeness. The implications extended even into planetary defense and monitoring strategies. If artificial objects could enter the solar system unnoticed, more advanced detection systems would be essential. The light emissions demonstrated that interstellar debris might carry more than inert material. It could carry technology, perhaps even instruments designed to observe the worlds they pass. This realization intensified calls for global cooperation, pushing space agencies toward higher-resolution telescopes, broader survey networks, and more sensitive instruments capable of detecting faint anomalies across the vastness of space. As the object continued its inward journey, increasingly refined observations added new depth to the mystery unfolding around it. Spectroscopic data revealed unusual reflection characteristics that did not align with exposed rock or simple ice. Certain wavelengths hinted at surfaces that appeared organized, possibly layered or segmented, though the immense distance and limited resolution prevented firm conclusions. Thermal scans detected faint areas of warmth that cannot be explained by passive heating from sunlight alone. While this did not confirm the presence of machinery, it supported the possibility of internal energy sources, however weak, still operating after unimaginable spans of time. One particularly compelling avenue of investigation examined whether the light pulses altered as Atlas encountered stronger solar radiation. Subtle changes in timing suggested the object might be responding to its environment. Whether this response was purely automatic or reflected some form of intentional regulation remained uncertain. If the emissions were adaptive in any way, it would imply a level of internal processing, even if minimal. Such a realization would radically alter humanity's understanding of extraterrestrial engineering, showing that machines could remain operational for millions of years while crossing interstellar space. As the object drew closer to the Sun, the philosophical impact of the discovery deepened. Humanity found itself at a rare crossroads where scientific observation blended with existential reflection. People began to wonder what it meant to be noticed, even indirectly, by something unknown, what it meant for Earth to be a point of reference within a vast cosmic landscape, perhaps one long forgotten. For some, the idea was thrilling, suggesting a galaxy populated by ancient travelers and silent observers. For others, it was unsettling, raising fears that humanity might be examined, recorded, or simply brushed past by remnants of forces beyond comprehension. Across the globe, more telescopes were turned toward Threeey Atlas than toward any interstellar visitor before it. Universities organized continuous monitoring efforts. Amateur astronomers contributed observations from personal setups. Space agencies exchanged data, testing models that linked the pulses to rotation, internal structure, or energy flow. Yet despite the overwhelming attention, the object yielded little clarity. The lights maintained their steady rhythm, unchanged, inscrutable, and seemingly indifferent to the intense scrutiny they inspired. As data accumulated, the broader significance of the discovery began to take shape. It did more than raise questions about extraterrestrial life. It challenged assumptions about how civilizations might leave traces of themselves across cosmic distances. If Atlas was technological in nature, the galaxy could be filled with drifting remnants, each carrying faint signatures awaiting detection. This led to an even more profound consideration: how many civilizations may have emerged before humanity, and how many might have scattered artifacts that now wander silently through interstellar space. The event also underscored the need for scientific humility. The universe, once assumed to operate within predictable frameworks, continued to reveal deeper layers of complexity. Humanity's understanding of interstellar objects had already been disrupted by Oumuamua's unexplained acceleration and Borisov's pristine cometary makeup. The luminous behavior of Atlas added yet another challenge, showing that not all phenomena fit neatly into established categories. Researchers were pushed to broaden their conceptual boundaries and reconsider ideas once dismissed as speculative. The signals from Atlas also reshaped the search for extraterrestrial intelligence. Rather than focusing exclusively on radio transmissions or planetary atmospheres, scientists emphasized the importance of identifying technosignatures, markers of technology rather than life itself. Artificial light stood out as a powerful example. If Atlas truly carried technology, it demonstrated that artifacts could traverse immense distances and remain detectable long after their creation. This realization spurred efforts to develop new analytical tools capable of identifying technological anomalies hidden within existing datasets. NASA's public acknowledgement played a crucial role in fostering open scientific exchange. Researchers around the world were encouraged to collaborate freely, unburdened by secrecy or stigma. Astronomers, physicists, engineers, biologists, and information theorists all examined the anomaly from their respective perspectives, enriching the investigation through interdisciplinary insight. As Threeey Atlas continued its path toward the inner solar system, humanity experienced a rare moment of collective focus. Curiosity transcended borders and cultures. The lights became a symbol of possibility, a reminder that the universe is not a static backdrop, but a living expanse filled with stories older and stranger than human imagination. Whether Atlas proved to be a relic of an ancient intelligence or a natural phenomenon beyond current understanding, its presence inspired profound awe. The signals persisted, steady and unchanging. They did not intensify or fade. They continued like the slow heartbeat of a traveler from another star. The more NASA observed, the more the lights seemed purposeful, even if their intent remained inaccessible. If Atlas was a machine, it was one designed to endure extreme distances and time scales. If it was natural, it defied every known classification. Either conclusion carried consequences that reshaped scientific thought. Humanity watched as the object moved deeper into the solar system, aware that the opportunity for observation was brief, yet transformative. The lights, impossibly consistent and hauntingly regular, stood as a reminder that the cosmos contains mysteries far beyond Earth's experience. No dramatic conclusion was necessary. NASA's confirmation of artificial-like signals from an interstellar object alone marked one of the most thought-provoking moments in human history. The journey of Threeey Atlas continued, unhurried and indifferent. Its enigmatic glow carried silently across the sky. The lights cast no answers, only a question that echoed through human thought, revealing a universe far older, more intricate, and stranger than humanity had ever imagined. As Atlas approached the inner boundary where sunlight grew stronger, each passing hour revealed details never before observed in an interstellar visitor. Earlier findings had already raised questions about structure, intent, and the source of the illumination. Now, new data introduced entirely fresh dimensions to the puzzle. Scientists quickly realized that the primary pulse pattern, remarkable as it was, represented only the surface of a much deeper complexity. As the object brightened in telescopic view, faint secondary flickers emerged, interwoven with the main pulses like fine threads in a larger design. These subtle variations did not follow the primary rhythm in timing or wavelength. Instead, they appeared as tightly packed microsequences, brief bursts detectable only through extreme signal amplification. The presence of these secondary flickers suggested a layered system rather than a single source of light. It hinted at internal processes operating independently, perhaps running multiple cycles at once. With each new observation, the mystery of Threeey Atlas deepened, offering no clarity, only a growing sense that humanity was witnessing something far more complex than a simple interstellar wanderer. When news of the discovery became public, intense debate immediately spread through the scientific community over its meaning. The layered nature of the emissions suggested that Atlas might not be a single, simple device or fragment. Instead, it could be modular, made up of interconnected systems designed to operate together or fulfill separate functions. Some researchers propose that the primary pulses controlled orientation or navigation, while the secondary flickers managed internal balance or thermal regulation. Others suggested the layers reflected distinct subsystems, remnants of a far larger design partially degraded by time, but still active enough to expose its underlying structure. If this complexity proved technological, it would point to engineering concepts far beyond human experience, optimized for durability, independence, and survival across the emptiness of interstellar space. Spectrographic analysis soon revealed another striking detail. Traces of elements appeared in ratios that did not match any known natural geological arrangement. The elements themselves were common, metals and minerals found throughout the universe, yet their distribution was unusually uniform, too precise to be random. They reflected light within narrow, consistent bands, as if deliberately arranged or alloyed. Some scientists propose that Atlas's surface might be coated or infused with materials designed to withstand radiation or micrometeoroid impacts. Others suggested the elemental balance could indicate substances engineered to manipulate light, either to protect internal systems or to emit signals outward. This possibility fueled speculation that the luminosity might function as a defensive or regulatory mechanism rather than a simple beacon. Further analysis also reshaped understanding of the object's rotation. Early data had suggested a slow, drifting spin typical of interstellar debris. New measurements, however, revealed irregular stabilization. Atlas would rotate smoothly for hours, then abruptly adjust its orientation in a way too precise to result from random forces. These corrections occurred almost exactly alongside subtle shifts in the pulse patterns, implying an internal system responding to changing conditions. If Atlas were merely a rock, such behavior would contradict established physics. Only an active or semi-active internal process could account for rotation correction at such exact intervals. This discovery influenced theories about the object's purpose. Some researchers propose that Atlas might be an inertial probe designed to preserve stable orientation for navigation or observation. Others imagined it as an automated craft whose systems continued striving to maintain alignment despite immense age and damage. It was even possible that Atlas no longer functioned as originally intended, yet continued executing routines embedded in its design. Routines that had survived countless encounters with cosmic hazards. While rotational adjustments drew attention, thermal imaging produced an even more puzzling result. Earlier scans had identified faint hotspots inconsistent with passive solar heating. New data revealed that these warm regions fluctuated according to an internal cycle. Every few hours, the hotspots intensified slightly before fading again, resembling the slow breathing of a system drawing on hidden energy sources. These variations loosely match the timing of the secondary pulse sequences, suggesting a link between thermal activity and light emissions. This correlation pointed toward internal energy conversion, possibly drawing from ancient reserves, cosmic radiation, or solar photons. One especially intriguing hypothesis suggested that Atlas might use exotic materials capable of storing radiation and releasing it in controlled intervals. In that case, the light pulses could be a byproduct of energy modulation. Alternatively, the emissions might serve as a deliberate release of excess energy to prevent overheating. Either explanation implied a level of engineering sophistication exceeding most human technology, particularly in terms of longevity and autonomous operation. As scientists worked to understand Atlas's structure, attention shifted to its movement through space. Detailed trajectory modeling revealed minuscule deviations, far too small to detect without advanced analysis, that resembled microscale propulsion effects. These deviations did not align with solar radiation pressure, gravitational disturbances, or outgassing. Instead, they appeared purposeful, as if the object were making subtle course corrections, though barely distinguishable from background noise. Their consistency ruled out coincidence. The notion that Atlas might be guiding itself, even in a limited way, sent shockwaves through the scientific world. If it possessed even rudimentary navigational ability, it would represent the first tangible evidence of non-human interstellar navigation. Such a finding would imply that some civilization, extinct or otherwise, once built a device capable of traveling between stars and interacting with its environment. The scale of this implication was enough to reshape entire scientific disciplines almost overnight, while trajectory adjustments hinted at deliberate motion. Another behavior deepened the mystery further. As Atlas passed through regions where solar wind density varied, its pulses appeared to adapt. In denser regions, the pulses became shorter but more intense. In less dense areas, they lengthened. This adaptability led some scientists to suggest that the light emissions functioned as a form of environmental sensing, using luminosity to evaluate surrounding space. If so, Atlas might possess sensors capable of interpreting spatial conditions through light. Another theory proposed that the pulses acted as optical shielding, adjusting output to counter changes in solar wind pressure, thereby stabilizing orientation or protecting internal components. Whatever their role, this responsiveness was unprecedented for an interstellar object. NASA acknowledged this adaptability, identifying it as one of the strongest indicators that Atlas might not be inert debris. As evidence accumulated, specialists from outside astronomy joined the discussion. Information theorists examined the pulse sequences for signs of encoded structure. Mathematicians studied interval relationships for patterns suggesting logical formatting. Engineers analyzed rotational and thermal behavior to infer mechanical principles. Linguists even speculated about whether the light could represent a form of communication. While such ideas remained speculative, the collaboration itself was unprecedented. Atlas became a focal point, bringing together experts who rarely interacted. This convergence generated new perspectives and hypotheses. Some suggested the pulses might encode star positions or temporal markers. Others proposed algorithms optimized for transmission across immense distances and timescales, without a means of interpretation. However, these ideas remained unproven. As Atlas moved closer to stronger sunlight, new visual details emerged. High magnification imaging revealed faint geometric patterns on its surface, barely visible shapes resembling grooves or channels. These features did not match natural fracturing or erosion. Their straight lines and intersections hinted at intentional design. Researchers debated whether the markings served structural, optical, or symbolic purposes. They might have functioned as part of a thermal management system or an optical grid. Alternatively, they could be remnants of a larger construct, traces of plating or shielding lost over time. Anthropologists and semioticians were intrigued by the possibility that the markings held symbolic meaning, a form of inscription. Yet, without cultural context, such interpretations remained purely speculative. Like the pulses themselves, the markings offered visibility without understanding. One of the most surprising developments came when Atlas was observed simultaneously in ultraviolet and infrared wavelengths. The pulses behaved differently across the spectrum. In ultraviolet light, they appeared sharper, with rapid rises and falls indicating quick energy transitions. In infrared, the pulses were smoother and more gradual, as if energy diffused through internal layers before reaching the surface. This contrast suggested a multi-stage emission process, with light generated internally and filtered through complex materials. Such a mechanism would be extremely difficult to produce naturally, strengthening the case for engineered components. At the same time, monitoring stations searched for radio emissions beyond the visible spectrum. No coherent radio signals were detected. Yet this absence became meaningful. If Atlas were technological, its creators may have favored optical or ultraviolet light over radio waves for communication or control. Radio signals disperse easily in interstellar space, while certain optical frequencies can remain stable across vast distances. The reliance on light could reflect design principles optimized for endurance across immense spans of time. If you enjoyed this video, please like and subscribe to the channel, and share your thoughts in the comments about NASA's decision to address the artificial-looking lights associated with Threeey Atlas. Thank you for watching, and we'll see you next time.